Section 2.1, example 1, finding the area of the region between two curves. So if R is a region bounded above by the graph of the function f of x and below by the graph of the function g of x over the interval from 1 to 4, find the area of region R. Let's take a look at what that looks like on a graph, graphically. So here in red, we have this function here. And in blue, we have this function right here. So with those two, we're looking at the region between 1 and 4. So this is where x is equal to 1 all the way to where x is equal to 4. So starting off there, we're looking for this region here. So now let's take a look at what our graph would look like normally. So normally we would have the function, so where the function is less than y, so f of x, where f of x is less than y, f of x is greater than y. So we're looking at all that region there. And more specifically, we could restrict the area. Let's restrict the area that we're looking at here. So from 1 to 4. So 1 is less than x, which is less than 4. So looking at that region, we have that, and we're looking at the area above the x-axis. So let's make one more restriction to our function here. So and let's go to 0. There we go. So this is what we normally look at. But now introducing this graph here, we've overshot it by all of this region right here. So we overshot this area right here. So we need to fix that. And the way we could fix it is just by looking at just that area. So subtracting everything that we've overshot, because we could easily find the area here. We could easily find that black area that we overshot, this one here, by finding the area of now g of x and subtracting it. So technically that's exactly what we're going to do computationally. So let's just see what that looks like. So starting off with our integral, we're integrating over x, and x goes from 1 to 4. And now we're integrating first that top function. So the top function is that x plus 4. And we're subtracting everything that we've overshot. So everything we overshot was that g of x function. So 3 minus 1 over 2x dx. And now from here, we could integrate like normally. But before we do that, let's think a little smarter, not harder. Let's combine like terms. So x's, we have minus, so that would be plus 3 over 2x. And then lastly, we have these values here. So 4 minus 3 is just going to be plus 1. Let's integrate. So we have that 3 over 2 x to the power 2. Let's multiply that 1/2. Plus x, we're evaluating all of that from 1 to 4. Let's simplify it. 3 over 4x squared plus x, evaluate it from 1 to 4. And let's evaluate at 4. So 3 over 4, 4 squared plus 4, minus 3 over 4, 1 squared plus 1. And we have 4 times 3 is 12, plus 4, minus 3 over 4, minus 1. So 16, 15 minus 3 over 4. So that's 14.25. 14.25, and there we go. If you have any questions, please feel free to ask. Otherwise, bye.